In a fast-paced tech environment, the potential attack surface increases with each release and new app created. Detectify automates cutting-edge knowledge from trusted ethical hackers into the development pipeline for reliable application security. Go beyond the OWASP Top 10. Check your web apps for over 2,000 known vulnerabilities actively exploited in the wild, monitor subdomains for potential takeovers, and remediate security issues in staging and production. Learn more with a free trial at securityweekly.com/detectify. Go hack yourself. Security teams need visibility into Linux systems to detect and investigate incidents and protect against unwanted activity. Operations teams are not down with downtime, and with revenue tied to uptime, ops priorities are enterprise priorities. Which is a higher priority? Why not both? Capsulate provides flexible, production-ready infrastructure protection for Linux systems, all without a kernel module. With ops-friendly production security, Capsulate delivers monitoring, detection, and response without adding operational risk or cost. Visit securityweekly.com/capsulate today to request a demo.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by Matt Alderman and John Kinsella. Do you want to stay in the loop on all things Security Weekly? Visit securityweekly.com/subscribe to subscribe on your favorite podcast catcher or our YouTube channel. Sign up for our mailing list and join our Discord server. If you missed our Security Weekly Unlocked last month, you can now access all of the content on demand, whether you registered before the live event or not. Just visit securityweekly.com/unlocked and click the button to register or log right in. Matt, so glad you could join us this week because there is some fun news in vulnerability land today, and fun news out of Qualys, no less. And all three of us have pretty fun and strong connections to Qualys, so it's really cool to see the research team over there. But they came up with a SUSU Studio, as I introduced it, Overflow, that was pretty pervasive in pretty much every Unix and Linux-based OS out there. And the only other thing I'll add before opening up the floor for discussion is that, wow, it was introduced in July 2011, and nobody noticed it since. So that's not a great look.
Back to open source and embedded components and capabilities. And when you find a bug in one and it's been used by everybody, now everybody's vulnerable. Yeah, I mean, we were just talking about pieces of this in the last segment, and it's great that this research came out of Qualys, and John was just on the last segment from Qualys. But yeah, how do you not notice this for basically almost 10 years? It's just been sitting there unnoticed for 10 years. And this is one of those interesting supply chain kind of discussions, right? We saw a huge attack at the end of last year that's been in the news all month long, last month with SolarWinds and some of the issues there. And here you have the ability to escalate privileges and major vulnerabilities in it. So basically anybody can take over the root of these Linux systems. It's crazy.
It is very crazy, and I included in the show notes also just a link to the original commit that introduced this, because as you pointed out, this is a great supply chain discussion to have, but also just a great, kind of codes review, code security type of exercise, because you have here a refactor of the code that changed parsing a command line argument. Now, that's important and should be considered sensitive because the command line argument is quite obviously something that can be is one of the most easy things for an attacker to influence. And in this case, it was also dealing with escapes and escaping input. You're now artificially modifying the size of that input, because is your backslash a literal, or is the backslash now actually collapsing characters? And so once you're starting to iterate through this string, you can hit some of those powers of two boundaries, and as we see here, heap overflow vulnerabilities happen, and it doesn't go well. So it's one of those things I'm highlighting in the sense of, even if we talk about the AppSec team coming in or the DevOps team doing code reviews, it's one thing to say with enough eyes all bugs are shallow, but I like to sort of reformulate that and say, sure, there's a lot of eyes, but many eyes are shallow, and they're not always going to notice these types of bugs, either because those eyes aren't trained to notice them, or there's just too much going on, or it's really easy to get confused between here's this plus, here's this iteration, am I at the boundary, or for the theme of the day, am I off by one?
Off by one.
Off by one. There was another vuln that also kind of tied to this that I think speaks a bit more to supply chain security. Not quite pervasive. It's a nasty bug, but it's not quite pervasive as sudo. This was in Libgcrypt. And this, again, was also similar in the sense that it was a flaw that was introduced 2 years ago, found by Tavis Ormandy, a very familiar name in research circles, part of Project Zero. But he highlighted in this, you could basically trigger this vulnerability through the decryption process before any signature validation or integrity checking was done. So this would actually be a really great way to trigger a bug by just saying, hey, decrypt this, bam, you've been compromised now. Fortunately, the impact was not quite as pervasive just because so far there's not as many people or many systems that have adopted this version of Libgcrypt. But so I think it's possibly a little bit harder to figure out and interrogate your systems on something like Libgcrypt and what's actually using it than it was with sudo. So just some suspicions there that it might be a little bit harder to root out, so to speak, where this vuln might exist.
I think that's a good point. I was gritting my teeth a little bit in honesty when Matt was referring to the sudo issue as a supply chain. And it is at that top level, but it's very easy to know if sudo is in your system or not. Or where it is. I mean, we can we can presume it's not your system.
You can pretty much guarantee it's in your system.
Yeah. But with Libgcrypt, yeah, and then what version? This is, I think, a little more of the issue we've really been dealing with. It's glad to see they caught her and hopped on top of even those like this. It's funny. I just as we talk about supply chain security and all those type of things, I've started recreating a GPG key and signing everything I commit and push. So I had happy thoughts about GPG recently until I saw this, because if you look at the process of generating a key now compared to where it was a few years ago, the defaults are a lot better. It's a lot better experience, and the results are a little more secure, as long as you're not running this version of Libgcrypt. Whoops.
Yes, definitely a whoops. And I think one other thing I was looking at my notes is that we were talking in the last segment with John about a little bit about certifications, but I think more about the spirit of education and kind of that feedback cycle, or that call it crash analysis. That there was another thing that on the sudo side is that when someone was looking to reproduce this particular vulnerability, they also discovered that there was a no root mailer, or basically was this other somewhat related capability to not run another process as root, just didn't work. And this was also interesting because, it was a good example of saying, here's a problem with sudo. Let's go investigate it, but there's a code smell here, and maybe let's poke around. And here it was a matter of luck in identifying this no root mailer flaw. But it's a really good way of an exercise to say, we missed something for 11 years. Let's actually take some time and review this architecture, review these ideas and assumptions, and think, where are our security boundaries, and are they being enforced in the ways that we're thinking? And we would apply that perhaps in this Libgcrypt scenario to say, we're decrypting, but should we have validated the signature first, or should we even check the integrity first before even trying to decrypt this? So a couple food for thought is just what I would throw out there as ways of thinking about how we might react to these types of vulns.
It's funny. Thanks for bringing that back up. I had started talking about that the follow-on on the sudo segment. Then I realized I was on mute, and you went off to the next topic. But in a way, it's a regression, right? I mean, it's not specifically, but that's the type of thing you'd find in a regression test. It's like you'd gone through and tested everything before, and there was no vulnerabilities that you knew of. But if you have a decent regression suite, big if there. But if you do, and then you fix something, what else what's the cascading effects? And it's I'll leave out how do you actually categorize that in your Jira, whatever else, because it's not a new security issue. It's a security issue was there before, but still it's a good example for why you need a decent regression suite.
Absolutely. And I think that gives us a way also, too, to segue into the next topic about iMessage and BlastDoors. We even started off this year, our first podcast, John, you and I had a fun conversation about security by design. And I thought this right up from Project Zero, so Google doing some great security marketing, if you will, for iMessage, with talking about BlastDoor and the iMessage security architecture changes that came with iOS 14. And some of the neat things that stood out to me is that they are going after fundamental exploit change or fundamental parts of the exploit chain and making those really that much harder. So they're not just saying, oh, for example, we had a cross-site scripting, we need to go fix this one particular cross-site scripting. They're saying, we deal with user-generated content. We deal with message parsing. And those are two aspects that we didn't talk enough about, perhaps with John from Qualys in the last segment, in the sense that when he was telling us file uploads were two very major parts of the repetition of vulns that we see. And we've even talked about file uploads of images in many episodes here, as well as parsing text files, parsing XML files, parsing image files, and how often those lead to vulnerabilities. So here is iMessage, which parses text, parses images, possibly parses XML that encapsulate those images and texts, and what Apple has done to make that a lot more secure framework as a way it goes through that state machine of processing. So this one really was neat to me. It definitely gets into some technical details that I think are appealing, but those technical details you could possibly skip over and still appreciate the architecture of what's going on here.
Yeah, and I think what's interesting, there's a couple things that really kind of stood out to me, which was they're using Swift, which is a memory-safe language, right? So they're trying to protect memory. The other thing here is that they're re-randomizing the shared cache regions, right? So that these attacks can't propagate. It's just some interesting protections when you think about memory manipulation and how to prevent some of these attacks from happening. Those are just a couple of the very interesting things that they implemented in iOS 14 to better protect against some of these exploits.
That's a great point, because when ASLR was introduced, it was this idea that, awesome, we now are going to just randomize our address space, and we're going to make it that much harder to do these attacks. But then attackers quickly realize, oh, look, we have all this return-oriented programming because all of these system libraries pretty much don't get re-randomized. So suddenly ASLR was not at all as effective as we thought. But as you point out, Matt, Apple's looking at this and saying, well, we had this capability that on paper seemed to work, never really worked, but why was that flaw? Should we get rid of ASLR, or should we do something that makes ASLR more effective again? And it was really nice to see that rather than throw it away and give up, they went and did that, what they called that shared cache resliding in the write-up, which is really neat.
Yeah, but the problem, I think the one still little gotcha, I think, is that service has to be restarted. So you either have to force a restart, or users have to periodically restart those services for re-randomization. So I still think there's a window in there for the attacker. The question is, how do you minimize that window?
Yeah, fantastic point. Yeah.
What's sort of interesting about this? So let's see. There was another paper that came out. I think last week, I can't remember if we covered it, but basically some researchers went through and looked at the capabilities of iOS versus the security and crypto capabilities of the iOS versus what's actually being used. And the conclusion was it could be so much more secure, but this is what they're giving us. But I want to go back a little bit further still. And I think, we talked about it when we did a segment about, designing for security and secure code. And I think one of the things we're both talking about, Mike, is, we don't have ultimate time. It's so how do you take the time you have and figure out where you need to actually focus it? And this is sort of a really good example of this, right? They got tired sometime last summer of dealing with all these injection attacks and of that general category. And they're like, right, that's obviously a vector which people are using. How can we fix that, right, and just not have this issue again? So I thought that was really interesting. It's a really good example of you don't have to make your whole application secure. It's like really focus on where things are coming from. And then the second thing, we've talked and joked about the if you have an image handler or if you're a chat app that's allowing people to do previews of images, all these different types of things, it's just a matter of time. And Google sort of drew out this diagram. I think you referred to the state diagram of the steps that you really have to I'll say that Apple has to go through, because it's several different programs, to really just display a message from the moment you get a push request and actually, decoding it, defusing it. Then is there attachments? Okay, dealing with those. It sounds, simple, but it's a complex thing. So I think that's a good visual for folks who want to sort of really understand what the problem is here.
I think so, and there's some bits speaking of Google, there's some bits I would generalize too in terms of hardening message passing or hardening these types of state transitions in the sense of protobufs. So protobufs are a really solid way of maintaining the integrity of your messages and handing them off either within IPCs or through different APIs sitting on very different networks. And one of the reasons I like that is that now you're getting rid of some of these deserialization attacks that were really the attacks du jour, just like CSRF was maybe around 2008 or so, or for a couple of years before that went away. Deserialization attacks popped onto the OWASP top 10, became really cool, really, really fun to focus on. And then hopefully we have something like protobufs or different architecture choices that we're using that make those types of vulnerabilities, those classes of vulnerabilities, just harder to introduce. Speaking of security by design, there was sort of security by explanation, just a PDF I linked to about an overview of AWS Lambda. Now, I don't think there was anything too earth-shattering or quite as intriguing about how things have changed within Lambdas, like we saw from the Project Zero write-up in iMessage BlastDoors. But I wanted to pull it out as just a great way to have a good understanding from a threat modeling perspective of what do Lambdas protect, what security assumptions do they bring to the table, what security assumptions can we make about them, and what's our comfort level in the security boundaries they establish. And I would highlight there is, I forget the page now, I think it was maybe page, let's see if I remember, page 9 that has a really neat figure that just talks about the isolation model for AWS Lambda. So again, just a really cool thing in the sense of good information rather than just talking about vulns all the time. So wanted to highlight that one.
It's funny, the timing on this. I didn't get the link into our show notes, but someone, I want to say Thursday or Friday last week, they released a bit of research showing that they figured out how to, on Azure functions, escape out of the container, but they're still in the Hyper-V virtual machine. Amazon's using Firecracker, so it's interesting to keep in mind that while these serverless things, taking a look at that diagram and actually understanding how they work. Here goes me with my looking at pictures again, but understanding the framework and how that stuff works. I think it's something people should really understand before they start using serverless. It sounds sort of magical, but what type of containment are you in? How do you see versus what your neighboring functions see versus another customer? How are you separated from them? I think people should really have a pretty good understanding. Not that there's a weakness in it, but I think people need to not just use it with a touch of the magic wand.
No, a great point. And I sort of wanted to use those to build us up to this other article that seems old at first, but I think it can be a fun way to talk about security by design as well as feedback loops and call them pre-mortems, if you will. So Stack Overflow talked about, they posted a blog update about a 2009 compromise that they experienced. And it's pretty interesting document about almost like the entire month of May 2019 and what they went through. And it was neat to see just from this perspective of transparency. This is what happens during an incident, or here's at least some of what happens during an incident. But what stood out to me is that near the end of it, they have a section called Advice to Others. And I kind of like that from the idea of here is a company talking about a breach. So not necessarily being ashamed, because breaches can happen. They do happen. And so it's great to share what can we learn from that. And this advice to others, it's pretty high level, but I think that could be really good for starting a conversation with your DevOps team, or even if you have a product security incident response team or a CSIRT team, to say, how well could we respond to a similar scenario here? Do we have this type of logging in place? Could we have detected this? Is this even the type of vulnerability that might affect us? And I think those are really good ways to start that conversation and get some threat modeling going and engage your developers on their own creative thinking, rather than always just be security coming and saying, hey, here's a checklist of all the things you need to do.
What I like about the list here is we've covered pieces of these on other shows, like the first one, log all inbound traffic, right? We interviewed ExtraHop last week. They actually saw the lateral movement attacks at SolarWinds, for example. They just didn't know it was the SolarWinds attack because they didn't have the IOCs.
Cool.
So the ability to see the traffic means, if you're collecting it all, you can actually see some of these attacks happening real time. You can see the command and control. You can see the weird DNS queries that were happening, et cetera, et cetera. So I love this first recommendation because they were seeing behavioral attacks. Now they know they were SolarWinds attacks because now the threat intelligence and the indicators have come out, and they went back in retrospect and validated it. So this first recommendation, I think, is huge for people. The network doesn't lie, so if you've got it, it's a base source of truth. The next two are all around credentials, right? It's do a better job of protecting your secrets, and then using multi-factor authentication to protect logins. These are a couple things we've talked about for a while.
Yeah, I think just good things. Remember the fundamentals. For as much as it is fun to, last week I had a great time talking about regexes and image parsing, and this week we talked about, again, command line argument parsing and sudo, but logging, asset inventory, these are still they're not as exciting, but they're pretty simple things to say, but complex to get right. And I think that is trying to help us with these last two articles. I tried to lump together that a pragmatic approach to DevSecOps, which I think is just kind of a bit of a reminder of a lot of high-level things about to think of when we talk about DevSecOps. So I'm not sure that there's much necessarily that there's a great insight to steal from, other than just read, be aware. And it ties into as well of a little bit of predictions. Now, I picked up these predictions because we were talking about Groundhog Day and repeating ourselves. And rather than try to just put on our hats and say, what's 2021 going to look like? And let's make some predictions and check them at the end of the year. I sort of wanted to use this to tease out what are some of the trends and areas of focus that people are thinking of, and do they apply to our own organizations? And two things to me that stood out as possibly more applicable were IDE integration. Everything, moving as much as possible into the IDE, which I think makes sense. Let's have the user experience, the developer experience front and center for building and securing applications. And there were a couple other of those items, but rather than me go through them all myself or highlight, I'm curious, John, if what you thought about this, and of course Matt as well.
No, pretty pictures did not read. No, I'm joking. My favorite thing actually on the list was it was a phrase I hadn't heard of before, CIPD. So I'm like, what's that? I usually think CI/CD. And PD, high-level TLDR, is basically progressive rollouts. So in other words, or progressive deployments. And he's using it from or I guess people are using it from the concept of don't just, when you release a new version of your code, blast out all your systems, but roll it out to some, test the water, see what happens. If things look good, then keep doing the deployment. And that concept itself isn't new, but hearing it as a phrase was interesting. His mention of Rust in here I thought was sort of cool. I've been getting more active with CNCF over the last month or two, sort of unofficial New Year's resolution. But so it's interesting as I go through things and seeing what he's talking about. There's obviously a CNCF-y list, if I can use that phrase. Rust was cool. Use of the developer dashboards. I'm hearing some folks talk about that. I'm curious to see how does that actually, is that actually going to get acceptance? There's two projects he mentioned. I've looked at Backstage. I'm not as familiar with the Clutch, but basically the idea: can you provide a dashboard for your developers for doing some of these components instead of rewriting the internal tools from scratch? And eBPF we've been talking about for a while, or the industry's been talking about. We'll see if it actually gets pickup or acceptance.
Yeah, the one interesting piece in this one for me was this concept of WebAssembly replacing scripting languages. And I'm curious if either of you have played with WebAssembly, because I don't see it as a popular technique, but is there something valid in this description that says, look, if I can do the WebAssembly, do I replace some of this? Does that potentially minimize vulnerabilities? Just curious if you guys have played with it.
Yeah,
so there's some neat work that Cloudflare has been. Oh, go ahead.
Oh, go ahead first.
Well, I was going to say WebAssembly and Cloudflare has been doing some neat work for at least maybe 5 years. That might be too long, but for at least quite a bit of time, the Cloudflare has been talking about this and their edge workers, if you will. And at the time, it was interesting to me in the idea of just offloading certain aspects. Basically, if it's JavaScript, it could become WebAssembly. And basically, you can compile your JavaScript into bytecode, which sounds a bit, ouch, my brain hurts. No, why would you do that? But hey, if we can actually have a subset of JavaScript that can go into WebAssembly, and that subset can be better understood, better sanitized with LLVM and so on, I think that's interesting. What stood out for me is that it's great to move to the edge, but there's a couple things that I still need to have either guarantees or more confidence in, and that's around secrets management in the edge. Because it's one thing to say, cool, we can have all these WebAssembly workers sitting out here, but if they need to do anything with data handling or encrypting payloads or encrypted workflows, I need to get secrets out there. So I need to make sure that I'm able to manage those secrets in a secure way, and that I know the edge is handling those in a secure way, whether that is that idea of lambdas, call it that perspective, or just WebAssembly and JavaScript. But that's where I'm still a little bit hung up on just figuring out that where where the real good adoption can finally kick in on.
That's a good one. I think a lot of us just think of Vault. I'm not sure. Is Vault part of CNCF? I know HashiCorp is part of CNCF, but if not, that's one. And then one I missed also, I mean, that's super important, right? That's like, as soon as we start talking to devs about, see that string there, get it out of the code, they're like, well, where do you want me to put it?
Right.
I don't know.
A Lambda function.
Just anywhere else, not there. And then the other one, though, that we didn't mention, the cube cost? Yeah. Is super interesting. Yes. So, too many orgs, especially startups, they don't manage the cost of that. Their spending control in public cloud. Like, I've always been a fan of Netflix's ICE. It got forked off and someone else has it now, but that lets you see what's going on with your Amazon. Like, when you've got these systems are so complex, you might spin up a system, the dev system, and then a day or two later you forget about it, or you're like, a habit of mine is I'll use one region for prod, one region for R&D, and then maybe I want to clone that, so I'll put it into another region, then I'll forget about it, and I don't even see when I log into a dashboard. So if I don't have some graph or something that's showing me, hey, there's a spend happening over there. So hopefully KubeCost can do that for within the cluster itself. So instead of having this black box that's sucking on your credit card, you have some idea of what pods or what's actually causing the financial load in there.
Yeah, and that was actually the other one that I really wanted to highlight. That idea of one, money is a pretty easy metric to quantify, and it's also one that people pay quite a bit of attention to because it costs money, which sounds kind of dumb as I say that out loud. So I apologize for that one. But if we're looking at the idea of how much money are we spending, and are we overspending it, or are we spinning up instances incorrectly, or are we mishandling load or storage, or not paying attention to our traffic costs? That's great, because I think there's a story then that can come out of that from a security perspective. And it either could be we want to overlay this particular security control, and this control has, let's just make up some numbers and say, has a 10% overhead. So we need 10% more instances just to serve the same number of queries per second. Or here is another security control that's allowing us to maintain availability or resiliency. And that's availability is a pretty important part of that CIA triad. So for me, looking at money, hopefully and having that exercise in that really good effective metrics, I don't have a path here, but I'm kind of waving my magic wand or sort of hoping that there's a path here to security and quantifying some useful security metrics as well.
Maybe.
I mean, that goes all the way back to, like, you're making me think of Cliff Stoll and the Cuckoo's Egg, right? That's how he first found that attacker in their system. It's like, what was it,
like 83 cents off or something? Yeah, exactly.
Yeah.
Yeah, what does this cost? So there we are. What does the sound of silence cost on a online live podcast? But I think that so what was our journey here? To try not to repeat ourselves too much, we went from the vulnerabilities of Sudo and Libgcrypt into the secure by design architecture of iMessage and BlastDoors and a little bit of Lambda to what that future looks like for the cloud. And I think if I'm trying to tie this back to our discussion with John in the last segment, one would be, rather than training developers about an OWASP top 10 point, I would love the idea if we train them on secure architectures. Take that example of Lambda or BlastDoors and say, here are some isolation concepts. Here are some security boundaries where we're parsing the message, then handing over the message for computation for some other purpose. And say, how does this apply to our application? How would we re-implement this type of isolation and sandboxing? And those are the conversations and types of training I would love to see. So that's my homework for the week for listeners. Are there resources or more examples out there that you have that you'd love to share with us? Because we'd love to talk about more of those as much as we'd love to talk about regexes and image parsing problems. So let us know. I don't know, Matt or John, any homework you want to assign to our listeners for this week? It's a new February, so we've got to do something. Listen to Business Security Weekly?
Well, we're going to get into GameStop and Reddit, so yeah, that might be some research people want to do later.
There we go. Speaking of money, that's our segue.
Speaking of money and homework, everyone needs to go find a big warm fuzzy jacket like Matt. Excuse me, Mike. Yeah, Matt. Too many M's. Too many M's,
too many Johns. But always a great time. So thanks everyone for joining us. Thank you, Matt and John, for joining me as well. We'll see you all next week on Application Security Weekly.